Welcome to the Health Workforce Technical Assistance Center's webinar series. This webinar is entitled Cartography 101, Map-Making Tips to Engage Stakeholders, and it was presented by Katie Gaul on April 26, 2017.
Hello, my name is David Armstrong, and I'm the Director of the Health Workforce Technical Assistance Center. In today's presentation, focuses on map-making tips to engage stakeholders. But before we get started, I'd like to introduce today's speaker. Today's presenter is Katie Gaul, and she's the Deputy Director of the Health Workforce Technical Assistance Center. And at this point in time, I'm just going to go ahead and turn the event over to Katie. After the presentation, you may ask questions using the chat panel on the right of your screen. And make sure you send your questions to all panelists to ensure that they have an opportunity to be answered. Also, when the event ends, you will be directed to a short evaluation survey. So please take a few moments to provide us with your feedback. We'd really appreciate it. Katie?
All right. Can everyone hear me? I hope so. So thanks for having me, David. And hi, everyone. I'm going to talk to you today about the basics of map making. A lot of people are able to make maps now with a lot of new tools that are coming out online. Software is easier to use, but there are still a lot of bad maps out there. So hopefully the tips I'll give you today will help you make good maps, or at least help give you something else to think about. My background is in geography, and specifically cartography, making maps, GIS, and medical and health geography. I started as a graduate research assistant at the Shep Center in 2000, and my job was to make maps for 20 hours a week for the Rural Health Research Program, and it was the best job ever. And then I finished my program, and I got hired at Shep, and that became the best job ever. And I got to keep making maps. So the tips I'm sharing with you today are based on what I learned in school and what I've learned along the way. So with that, we will get going. All right, so I'm going to talk a little bit today about why maps are important, and since you're on this webinar, you have an idea that maps are important to you. You're at least curious. I'm going to talk a little bit about GIS, but this is not going to be a talk specifically about GIS or about spatial analysis, but this will get the ball rolling to introduce the topic for future webinars. Then I'm going to jump into the basics of making a map. What makes a good map? And I have a list here. You need to know your audience. You need to know your data. You need to know the different kinds of maps that there are that would best show your data. And then, as I think David mentioned, there's going to be an evaluation at the end of this webinar. I encourage you to fill that out, partly because I want to know how you think I did, if there's anything I could do better or differently. But also, we have a few questions on there to see what you might be interested in hearing more about later on. So if you might be interested in software-specific demonstrations, we want to know that. And if there are other webinar topics that you might be interested in. So please fill that out when you log off the webinar. All right. I'd like to try something so I can get a sense of how much you might know about making maps. So maybe at the bottom right of your screen or the middle right, or if you have your screen in full screen mode, there might be a green tab at the top. You'll be looking for a feedback button, which looks like a dark comment box with a check mark in it. If you click that box, you should get the options. You see a box here that it's highlighted yes. What I'm asking you to do is check either yes or no when I ask you questions, and I'll give you just a second to try to find that button. And then I'll ask the first question. We'll give you some time to answer, and then David will clear it, and we'll start again. All right, so this first show of hands, this first yes, no. I'm wondering, have you or has someone else in your office made maps? Can you or someone in your office make a map? So find that feedback button and please check either yes or no. Okay, great. 21, 22 of you are saying yes, you've made a map, or someone else in your office can make a map. Great. All right, David, could you clear those, please, and we'll do it again. All right. Now, if you make a map or someone in your office makes maps, what software do you use? First one, do you use ArcGIS? Yes or no? 15 of you mentioned you use ArcGIS. Okay, good. That's what is generally known as the industry standard, so that's good. All right, David, please clear. Okay. Now, do you or someone else you know in your office use MapInfo? That's another GIS package. Yes or no? Go. All right, and 6 yeses, 13 nos. Okay, so MapInfo is not quite as well known as ArcGIS, and that's normal. I like MapInfo. I use MapInfo myself. All right, David, you can clear those. And we're going to ask about QGIS. Does anyone use QGIS? Go. Yes or no? All right. Yeah, most of you don't use QGIS. That's okay. QGIS is an open source free software package that some people use, but it's not nearly as well known as the others. If you use another package, it could be Tableau, it could be design software, it could be something else, maybe send me a chat in the chat box or put that on the evaluation at the end. So, all right, David, you can clear those, and thanks everyone for participating. Now, what's the big deal about maps? And I know some of you make maps, a good chunk of you make maps, and that's awesome. Simply put, a map takes your data from a table, from just a jumble of numbers, and it turns it into a pretty picture where you can see patterns and you can start asking questions. Pictures catch people's attention. Pictures worth 1,000 words. Not everyone can read a table. They don't understand a table. It's just a mess of numbers and they don't know what's going on. But when you put it in a map, people start understanding and they start going ooh and ah. Different ways to make a map. You can draw it by hand, and that's great if you're an artist, but so many of us are not. I can't draw anything. I would not be a cartographer if we had to draw our maps by hand. You can color in, you can shade in outlines. I have some people at UNC that have done that before. They gave me a hand-colored map, and it's really fun and to see, and then I make it into a nice, pretty PowerPoint map for them. You can make maps in PowerPoint. There's also Microsoft MapPoint, but clicking and shading in PowerPoint is tedious. It's prone to user error, but it is one method, and I send PowerPoint maps to people to make their own maps on occasion. But the best way to do it, the most efficient way to do it, is to use software or online tools. So, and I'll get to software and online tools in a bit. So what's GIS? Geographic Information System is a system to combine hardware, so your computers, digitizing tablets, and other hardware, your GIS software, and your data. This allows you to visualize, question, analyze, and interpret data to understand relationships, patterns, and trends. That's kind of a canned definition of GIS from some online sources. Basically, at its heart, GIS allows you to take your data in a data table and connect it to a map file, and it's shapefile in ArcGIS, a table in MapInfo, and it allows you to see those data on a map. It lets you layer different types of data so you can analyze between layers and see different layers one on top of the other. It lets you translate your data into meaningful results. And in GIS and spatial data, you have vector data, which are your points, lines, polygons. You can think of this kind of like drawing shapes in PowerPoint, where you can draw a point, you can draw a line, you can draw a rectangle. And then you also have raster information. And this is images built on pixels. So think of a JPEG. Think of an image you might bring into Photoshop. As I mentioned, GIS uses layers. You can bring in all sorts of layers. So in our world, your layers might be counties and zip codes. You might have your own rational service areas in your state. You might use census areas like census tracts. You might put in cities that are points, or maybe your cities are an area. You could bring in road networks, highways, interstates, back roads, healthcare professionals, healthcare facilities. You can bring in universities and colleges so you can see the relation or the location of training institutions relative to where your population is or where your healthcare professionals are. You can bring in other information too. So with all of these different layers, you can start asking questions and seeing patterns. Maybe you're looking at the uninsured population and roads and topography. So like Western North Carolina, we have mountains. You can start to identify gaps in access to care and start coming up with solutions to fix those gaps. We've already gone over briefly some examples. So ArcGIS, MapInfo, and QGIS are types of specific GIS software packages. There's also Cartographica, which one of our Mac users here at Sheps uses. He said it's really easy to make a map, but it's not very easy to polish the map with colors and legends. You have cartographic software. It takes out some of the intelligence of GIS where you can do analysis, but it does let you translate your data into a map. So these might be Microsoft MapPoint, also your online tools like Tableau and Carto. You have design software. There's a plugin for Adobe Illustrator called Map Publisher. That's a way to bring data into a map in Illustrator, and it allows you greater control of design principles. And Map Publisher can do a bunch of other things, including make interactive maps. There's also CorelDRAW, which is another design package. I tend to use MapInfo in conjunction with Adobe Illustrator because Adobe Illustrator lets me make it prettier. I have more control over font and text placement and colors. You can also make maps with some statistical software packages like SAS and Stata. I'm not a programmer. I don't use these packages very much. I know that the maps that used to come out of SAS and Stata were not always very pretty, but it let you see your data. I think they're coming along. They're improving, but I don't know the current status. And then, again, not GIS. You're seeing a lot more interactive maps, and these are created in a web development environment where people are using JavaScript and the D3 JavaScript library. Those are unique skill sets. They're different from normal GIS and cartography skill sets, but that's another set of software that you can use to make maps. Here's a short selection of online tools. I know some of you have heard of Tableau, some of you use Tableau. It's becoming a very popular online data visualization suite. Tableau allows you to make maps. And there's another package called Carto, used to be called CartoDB. That's another package that allows you to make online maps, but it focuses more on maps as opposed to other data visualization formats like charts and tables. HRSA Data Warehouse has a mapping service, a map tool, so you can download spatial files from them. You can download shape files, you can download data. So if this, for instance, might be a webinar topic, if you want to learn more about the HRSA Data Warehouse, perhaps that's something we can think about. And then this is not necessarily a GIS tool to use for your own maps, but the Robert Graham Center has a series of mappers built on a platform called Health Landscape. And for some of you who are PCOs or work with your offices of rural health, some of these mappers might come in handy because they look at community health centers or other information. And you can see what's going on in your state, and you might be able to use some of those tools to answer some of your own questions. So it's a little out of the scope of creating your own map, but it might still be useful. GIS and cartography have can have fairly steep learning curves. It takes a while to learn the software. It takes a while to learn the principles of cartography and how to make a pretty and an honest and a useful map. But there are places where you can get training. If you're affiliated with a university or community college, you can take formal classes, you can work with faculty. I know UNC Chapel Hill has a research hub that offers workshops on GIS and data visualization. Esri, ESRI, is the maker of ArcGIS, and they have a robust training platform. They have campus.esri.com where you can get online training. If your institution has a site license, this is often free with that site license. They also have in-person classes, and if you don't have a site license, you can pay for their training. They will teach to the ArcGIS software. There's also lynda.com, which I love. They now have mapping and GIS courses online. These are sets of courses that are made in short bits of video, so you can go to one topic and it might be 5 minutes, or you can do a whole course and it might be 4 hours. They also have classes on statistics, and it was, I think, originally meant for graphic design, so you'll get some color theory classes in there as well, and some other design classes that might be useful for cartography. Then there are other informal venues like today's webinar, or workshops at conferences. So there are a lot of materials out there. There are a lot of materials out there on the web. Some of the software platforms will have their own specific trainings and tutorials as well. All right, so let's jump into the basics of cartography. All right, so the first rule that applies to almost anything is know your audience. Is your audience technical? Are they focused on policy, or are they mainly research? Do they understand complex information, and how will they use the maps and data? If your audience is not very technical, say policymakers, they may not understand complex maps. So in those cases, maybe you want to distill the maps down to one specific message and keep it nice and simple. If you're mapping to a research audience, they might understand maps a little more and understand more complex information. But I will caution you, there's a book out there called How to Lie with Maps. You can do spectacular things with maps, and you can massage the message to almost anything you want because you have control over using different colors to influence people. You have control of how you break your data and your legends up to convey your message. So as you are making a map, cartographers have a responsibility to try to accurately and honestly portray the data they are mapping. Not everyone does this. People do have their own agendas. They do want to persuade people to think their way. But in our world, I encourage you and caution you to be very careful. Okay. Maps have common elements. Some are essential. I consider some to be optional. So on a map, you need a descriptive title. People need to know what you're showing them. You want a well-labeled legend, so when people look at the different colors or the different symbols, they know what they're looking at, and it's easy to figure out. You need your data source. Having the production information and a date is very useful. Give yourself credit where credit is due. It's produced by the Cecil G. Shep Center at the University of North Carolina at Chapel Hill. It was produced in April 2017. I put footnotes as needed as optional. If you have footnotes, put them on the map so people know what they're looking at. If you don't have notes, don't worry about putting them on. Other optional elements, depending on the type of map you're producing and the people you're talking to would be a distance scale, a north arrow, and a neat line. A neat line is a box around the map or part of the map that contains those map elements. It just keeps things nice and contained and nice and neat, hence the name neat line. On my maps, I tend not to put a distance scale or a north arrow. My audience is not usually measuring the distance between two counties or two features. I am showing them, for instance, the distribution of physicians per 10,000 population at the county level. So in my opinion, I do not need a distance scale for that map. There are a bunch of different kinds of maps, and this is just a sampling. I know these images are pretty small. If you want the full maps, I can send them to you. Just email me later. Choropleth maps are among the most common maps that we see. These are shaded area maps where your data go from, say, 0 to 100, or they just have different shades of color to portray different categories of data. You have graduated symbol maps that show bigger or smaller symbols depending on the data values. You have dot density, which shows you, like, say, population density, 100 people per square mile. In this example, I've put 1 dot equals 1 primary care physician or 1 specialist physician, and the dots are scattered randomly within the zip code area. You have flying pies. We call them flying pies at HWTAC, also just known as pie charts, or you can do bar charts. These are very complex. Some people love them, and some people hate them. And since we have both here at HWTAC, we usually tend not to do these kinds of maps, but they can be useful in their own right. These are pie charts, but it's also a graduated symbol map at the same time. You have a flow map. This map in particular shows the number of patients going from one county to a hospital. So it shows you how healthcare is being delivered in a way in North Carolina. And then you have just plain old dots. That's a very scientific and technical term. This map shows 1 dot for one type of healthcare facility, and these different healthcare facilities a different color. And there are other maps, other types of maps. There are heat maps and spike maps and all sorts of other options, but these are some of the most common. You have different data types. So you have points, lines, and polygons. Your points might be hospitals or other healthcare facilities. Your lines might be highways, and your polygons might be counties or zip code areas. You have different data types, and I'm not going to go into too much detail here, but the type of data you have will help determine what kind of map you're going to make. For core-based statistical area or CPSA designations, I'm probably going to do a shaded map, and I'm going to have 3 different colors. If I'm going to show ratios of physicians per 10,000 population, I'm going to set my colors and my legend categories specifically. I'm probably going to map this at the county level. All right. There are different ways to break up your legend. There are natural breaks, which have categories based on breaks in your data distribution. Some software packages do this in different ways, so sometimes it's kind of hard to explain to people how you do this. There is equal count, where you have an equal number of observations in each legend category. So, for example, in North Carolina, we have 100 counties, and if I have 5 legend categories, I'm going to put 20 counties into each category. The legend categories will not necessarily be evenly spaced like equal interval would be. Equal interval is where each data range is equal. So, for instance, you might have 0 to 10, 10 to 20, 20 to 30, instead of 0 to 1, 1 to 5, 5 to 20, 20 to 30, depending on your data distribution. You can also break your legend categories based on standard deviation. Now, I will tell you that a lot of people, including myself, are statistically challenged. Standard deviations are not going to make sense to the majority of your audience. It's not to say you can't do it, it just might be harder to explain. Standard deviations breaks are based on the standard deviations around the mean, and it works best if you have a normal distribution within your data. And then there are custom ranges, and this, I'll tell you, this is mostly what I do, and that's because many times when I'm mapping distributions of healthcare providers, I want to show the counties that have no healthcare providers, or maybe I want to show the counties that have fewer health professionals than for HWTAC designation purposes, right? So they're prescribed ratios to be eligible for a health professional shortage area. So maybe I want to show those counties, and then I break my legend accordingly. So again, small graphics, but hopefully you get the idea. These maps are showing the exact same data. They're showing primary care physicians for 10,000 population in North Carolina in 2011. But each map breaks the legend categories up differently. So the top left uses natural breaks, and that legend is going to be really small, so you're going to have a hard time seeing the values. But again, I can send you the big maps if you're interested. Equal interval has a lot of lighter colored counties and only a couple dark counties. So that's a much different distribution than, say, the equal count map has. So depending on your data, depending on what you're trying to show, your distribution on the map is going to be different depending on which method you use to break your categories. All right. Color is very important when you are making maps. Sometimes color will make or break a map, to be honest. At the bottom are some examples. You can have one shade, so that shows light gray to dark gray on the bottom left. You feel light blue to dark blue or orange or whatever color you want. There are multi-hues, and one popular example is going from a light yellow to a dark blue, where the progression from light to dark is intuitive, and it gives you a little more flexibility to have more legend categories than if you're doing one hue, like light blue to dark blue. The eye is going to have an easier time seeing that multi-hue distribution than it would be for just one color shade. You can do a diverging color scheme where you have, say, in this example here at the bottom center, it's blue is the negative values and red are positive values. You have qualitative color schemes where one color is one particular value. It's not hierarchical necessarily. It'd be like having A, B, C, and D. And A is red, B is blue, C is yellow, and D is purple. And then you have a two-variable color scheme, which again is complex for people to understand. It's a little complex for making the map because you have to set your data up correctly and you have to know how to use the software correctly. But it allows you to show more information. So it's intriguing, but a little harder to make, a little harder to understand. So colors mean different things to different people. For example, to me, red means hot, red means death, red means Republican. Blue means Democrat, it means water, it means cool. So when I look at different colors, I think of different things. So as you think about your audience, it might be something to keep in mind. When you're deciding what colors to use, you need to think about how the map is going to be shown. Are you going to print it in color? Will it be copied in black and white? Will you be projecting it on a screen? Will you be looking at it on your computer monitor? Whenever I would make maps to project, until projectors got better in the last few years, I had to make my map and then I had to go to the conference room and test it on the projector because oftentimes it would completely change my colors and it would it would mess up the map. So when we presented it, it didn't work. One example of printing your maps in black and white is that diverging color maps, remember that blue and red example, those don't print well in black and white. So you want to be careful when you make those kinds of maps. Sometimes you have to put, say, a texture like cross-hatching or dots in on your positive or your negative to make it a little easier to see in black and white. You want to make sure there's enough contrast between your color categories. So when you're doing, say, 5 categories light to dark, you want to make sure that your 2 middle blues are easily distinguishable, both in color and in black and white. If you have too many ranges, it's hard to figure out which color goes with which legend category. You need to think about your audience. A fairly large chunk of people are colorblind, and avoid your red-green combinations. I know I call them stoplight maps, where you have red, yellow, and green data categories. It's great for people who aren't colorblind. Green means go, green means good, yellow is a warning or kind of medium, and red is stop or bad, but that does not translate into a map for colorblind people. And I've listed one website where you can test what your map will look like. And it looks like this when I did it. With my original image at the top left, I chose a red-green diverging scheme. The 2 images on the right are 2 forms of red-green color blindness. You can tell that there are variations in the shades, in the darker shades, but if you look at the couple middle shades, it's hard to figure out, is that supposed to be red or is it supposed to be green? And then the image at the bottom left is for a blue-green form of color blindness. In this particular example, you can tell the difference between the different shades, but you can see how different it looks from your original screen. And one resource that I absolutely love is colorbrewer.org. This was a site designed by Cynthia Brewer at Penn State and her colleagues. It lets you choose the number of data classes that you want. So you can go, I think, all the way up to maybe 11 or more categories, depending on the type of color scheme you choose or the nature of your data. You can choose sequential, so say light to dark. You can choose diverging, or you can choose qualitative. At the bottom left of the image, you can check boxes so that it only shows color schemes that are colorblind safe or printer friendly. You can add context, roads, and cities just to see how things will contrast with your color scheme. And then on the right, where it says hex and you have your 3 shades of blue, you can choose the color values that you want. So you could do RGB or CMYK. It will give you the actual values that you can type into your software or PowerPoint or whatever. And I use this for maps, but I also use it for just other design purposes. So great color resource. She's done a nice job with this tool. All right, I'm not going to spend much time on projections, but I thought it was important to mention. The Earth is round, and our maps are generally flat pieces of paper or flat monitors. So a projection is a way to take the round Earth and put it on a flat surface. There are lots of different types of projections. Some types of projections preserve different characteristics. So one projection might keep the area the size it is in real life. Some might preserve distance, and some might keep the shape. And this is really important when you're doing real spatial analysis. If you're just looking to make a pretty map and get your data out there, it might not be as important. At that point, sometimes it just becomes an aesthetic preference. Those are mostly the maps I make. And when I make state maps, I prefer to use state plane coordinate systems. And these are a couple examples of how different states look with different projections. You have regional equal area, and this looks like, if you picture a map of the U.S., it kind of curves up on either side. And so both for Maine and North Carolina, you see they're tilted, whereas state plane coordinate system gives you a shape that looks like it's more standing upright. To me, this is more appealing. Others, it really might not matter, but this is my preference. You're going to have different options, or it's going to be easier to work with projections in different software than it will be in others. So we're getting to the end here. I made a list of do's and don'ts, and I think what would be really fun is to do another webinar on good maps versus bad maps. So what do each look like? And let's just deconstruct the characteristics of good and bad maps. But for now, this will suffice. So on your do list, do use clean fonts, no less than 6 point. 6 point is pretty small, especially for older eyes. Don't use huge fonts like 50 points. Do what looks aesthetically pleasing, but keep the text clean. Try not to use more than 2 fonts at a time. Use clear text, so your titles, your legend descriptions, your footnotes, be succinct but be descriptive. You're using the map to convey your data. You don't want to fill it with text. Knowing your legend, knowing your data and knowing your audience, figure out how to use the appropriate map type, how to use the right legend breaks, and how to use the right colors to convey your message. I didn't talk about this earlier, but you want to balance your white space. Make the different map elements proportional to the space that you have. So give the most emphasis to your map. Have the title for North Carolina, I center it across the top because we're a wide state. For a taller, skinnier state, maybe you have the title and legend off to the side. Sometimes it's hard to figure out how exactly to do that, but the way I've done it is I make a map and I show it to people and say, what do you think? They say, oh, that looks awful. Your title is way too big. Or, really, I think you should put the title over here. Or, why'd you do it this way? I think you should do it this way. So seek feedback whenever you can. Do make sure that your colors print black and white, and definitely include your data source and give credit where credit is due. Don't clutter your map with unnecessary labels, text, or features. You want to convey your data. You want to convey your message. Don't mess that up with a bunch of other stuff. Don't try to load your map with too much information. Some maps get really complex. You have, say, shaded counties, and you have graduated symbols on top, and then you have dots to show your hospitals or your colleges. That's a lot of information. Think about how the user's going to process all that. Don't use too many legend breaks. If you use too many legend breaks, it's hard to interpret, and sometimes they're not very meaningful. Don't use hard-to-read fonts. Keep the cutesy fonts for other stuff. I put don't use clashing colors, and what I mean by that is don't, say, do a green map on a bright screaming yellow background. Don't use, say, pinks, bright pinks and bright oranges. Sometimes that can look good. Austin Powers movies do that. But on a map, especially for policymakers, try to keep the colors nice and clean and subtle. Do not knowingly manipulate your legend breaks and colors to influence your audience. In our world, at least for the research side, we're supposed to be objective. We're supposed to convey the information, and we let the policymakers make whatever decisions they can. This is a fine line to walk, but as cartographers, as the people making the maps, we're responsible for doing our best to portray the data honestly. And last, don't plagiarize. And yes, this is a map thing too. It doesn't just apply to reports and manuscripts and writing. There's some really nifty maps out there that you want to replicate. Ask for permission to replicate them if you're going to do that, or make enough changes, and color doesn't count. Make enough changes to make your own and give that other map a nod as data source. So those are just a few do's and don'ts. There are more, and you'll learn more of these as you go along and seek feedback from your peers and your audience. So to sum up, well-designed maps are going to catch your audience's attention. Our stakeholders seem to love maps. They look for their county. They look for clusters. They look for apply around their particular college, our policymakers compared to their congressional districts. Maps are very tweetable. And post them on Facebook. You can use them to start a conversation and get some dialogues going. Esri has these story maps, and you can use the maps to tell a story and provide more context that you would not normally be able to do on just a regular map. I've included a link here. There's a nice example from Vermont. There are other types of story maps that exist. I kind of flip through the gallery, the Esri gallery, and get some ideas. But this could be useful instead of writing a whole big report. Just throw up a couple story maps and give folks a bit of context. That's all I have for now. I'll open it up to questions, and David can help facilitate. If you have questions, please use the chat box, the chat panel, and David can send those my way. And then feel free to email me or call me if you have questions or just want to talk more about making maps. So thank you very much.
Thank you, Katie. That was very informative. And just a reminder to those of you in the audience, there will be a short evaluation survey after this event ends, and we would really like your feedback on the types of webinars you'd like to see us produce in the future. And just to reemphasize another point Katie made, we're also considering offering training sessions in specific software packages such as ArcGIS or Tableau, et cetera. And so if that's something you're interested in, let us know. I mean, we need to know that you're interested in order for us to take the time to prepare that. And with that said, Katie, I do have a few questions for you. Exactly how big of a learning curve is there for GIS and cartography? How hard is this stuff to learn?
So it depends how easy you find it to learn other software packages. Learning the software with a bit of training isn't too terrible. It'll take you a while to figure out, okay, well, you told me to join this data to the shapefile in this way, but it's not working. Why isn't it working? Oh, well, my data are a different type. You know, my FIPS are character in one file, but they're a number in another file, so I have to go fix that. A lot of times, it's the troubleshooting part that takes so long to learn. You can follow step-by-step instructions, but in GIS, I've run into a bunch of problems just trying to figure out, that was supposed to work, why doesn't it? So I spent my undergrad learning GIS, and I'm still not great at it. So there can be a steep learning curve, but if you think you're pretty good at learning new software, new techniques, it might go faster for you.
All right, thank you, Katie. And, you know, you discussed a lot of different types of software packages. Can you tell me the pros and cons of GIS software, like online software versus desktop software for GIS?
Part of it comes down to cost. Some of these online tools are free, but on the flip side, some of these tools have a public version, the free version, and once you make a map or upload your data to make a map, those become public. That's a problem if you're trying to map sensitive information or you don't want your data getting out so just anyone can find it. Desktop GIS software will give you more power, but it also comes at a cost. It can be fairly expensive if you don't work at somewhere like UNC that has a site license for ArcGIS. Many educational institutions will have some sort of site license, so faculty, staff, and students can get a copy of the software for free. The classes will teach to that software, so that's part of why ArcGIS is the industry standard. It's just that's what's taught, and that's what people have used. Esri, the software company, does a pretty good job working with educational institutions and state governments and maybe other public agencies to provide a discount to that software. So different pros and cons. The true GIS, the desktop GIS software, will probably be a little harder to get up and running with. It can be complex to install, and depending on the type of software you get, you know, some are server installations or some might be desktop installations. Some of the online tools are going to be a little better designed aesthetically, and those will be easier, potentially easier to share as well. So different pros, different cons. A lot of it comes down to cost and convenience.
Thank you, Katie. And just a reminder once more for those of you in the audience, you may ask questions using the chat panel on your screen. And as I say, that one just popped up, actually a couple. So, but first I have another question already prepared from you. How do you know when to use a map as opposed to, say, a table?
That's a really good question. I tend to default to graphics just because of my experience. People have an easier time looking at graphics and it breaks up the text. Tables are great if you need to show specific numbers or if you don't have 200 data values that you want to show. For instance, showing a table for a handful of counties or for counties in a state that doesn't have very many counties would be appropriate. If you want someone to refer to those numbers and cite those numbers, a table would be appropriate. If you want to summarize the data in a way that just gets the quick message across, you know, here are the counties that don't have as many physicians as these counties that have a ton, you know, that would be more appropriate for a map or some other type of graphic, in my opinion. There are probably more scientific ways to determine when to use a map versus when to use a table, but that's kind of my rule of thumb when I'm not looking at too many values and I just want a quick summary.
Thank you, Katie. First, I have a comment from one of our audience members. They recently bought Tableau and had hoped to be able to use Tableau maps in some of their reports, but ultimately they determined that the resolution, that is the DPI, was so poor that they weren't able to transfer them into Word documents. So that's something to keep in mind if you want to use Tableau for GIS purposes. And here's another question for you. Do you have any recommendations or limitations when it comes to using other layer types, especially rural urban commuting areas or RUCKUS in maps?
I'm not sure I quite understand that question, but here's my interpretation, and whoever asked that question, you know, chat in if you want to clarify. When you have different layers, they may not always be the same shapes. So you could have RUCKUS at the census tract level, but then you also have county boundaries. There are going to be some mismatches in some of your layers. If you're talking about, you know, using RUCKUS as opposed to CBSAs and using different variables to describe different things, that would be a different question, but I'm not sure that's what you're asking. Depending on the type of analysis you want to do, if you're truly doing spatial analysis, you can get around some of those differences in area when you do the analysis functions. I'm not sure that I've answered your question. If you have more questions about that, zip me an email or give me a call because I'm not sure I'm understanding the question quite right.
Okay, thank you, Katie. And if you have a follow-up, I can go ahead and ask you that right now. The audience member is just interested in to bring RUCKUS corresponding with existing layers.
Sorry, say that again.
She's just interested in bringing RUCKUS corresponding with existing layers. I guess, does that make sense?
Oh yeah. Well, yeah, sure. You could bring in RUCKUS as another layer. You would just have to know. You would either have to have a RUCKUS shapefile or base map layer already, or have zip codes or census tracts, I think, were the RUCKUS areas, and join your data to that shapefile or base map. But yeah, you can bring in all sorts of different layers, and you can turn different layers on and off to see on the map. And as you work with your layers, the layer on the bottom on the map is going to be on the bottom too. And so you start with your, say if you're mapping counties and healthcare facilities, you want your county layer on the bottom so you can see the health facility points on top. So bringing in those other layers is fine. It just depends how you set the properties to see that layer in conjunction with your other layers.
Katie, that was the question and answer she was looking for, so thank you.
Okay, cool.
Okay, here's another question. It's from an individual who uses ArcGIS, and he's curious about if MapInfo handles interpolations like IDW, or I'm not quite familiar with this term, perhaps you are key ringing as well.
Kriging.
Kriging. Okay, thank you. Like I said, you're the mapper here, not me.
Yeah, and it's been so long since I've done real GIS. I've been mostly just a cartographer for the last several years, but I've lost some of my GIS skills. Yes, I think so, but whenever I had to do spatial analysis, like for interpolation and kriging, I would have used ArcGIS. So I have both ArcGIS because we have a site license and MapInfo because we purchased it for a couple of us here at SHEPS. So mostly I use MapInfo just to make my maps, and I would use ArcGIS for the heavy-duty spatial analysis, which would be the interpolation and kriging. But I think that MapInfo should have that functionality as a GIS package. I just don't use those functions.
All right, thank you, Katie. We have one more question here, and so let's go ahead and try to answer this one, and then we'll wrap up the event. In your opinion, what is the value of reproducibility in making maps? That is, meaning you or someone else can remake a map. My experience with Tableau is that it can be hard to reproduce a map or other visualization if my data are updated every 3 months. For example, do GIS software packages make this easier to do?
In ArcGIS, you can create scripts. I know there's Python, there's Visual Basic. There are programming languages you can use to just update your map with new data sources. In MapInfo, I can bring my workspace into a text editor, and I can say, okay, use this file instead, and update the years to 2016. I do that when I have to update my annual maps, and it goes a lot faster. So the short answer is yes. I think some GIS packages will give you more flexibility to do that. ArcGIS, you just might need to know a scripting language, and that's not something everyone knows. I think I am convinced that I cannot code. My brain just does not think that way. So scripting would not be an option for me, but going into a text editor to make my changes.
Okay, thank you, Katie. And thank you in the audience for attending our event. And just a reminder, please fill out the evaluation survey afterwards and give us your feedback. We'd love to hear from you and know what types of webinars you'd like to see in the future.
And thank you out there for attending our webinar. Just to let you know, we will be posting our slides shortly to our website. So if you want to download them, check back very quickly at healthworkforceta.org. We hope to see you again in the future. Thank you, and have a good day.